Three. Hello everyone, welcome to our group recording on ENG 3102 Economic Engineering. So our team consists of Lee Wensen, Khoo Dung Wai, No Nabil, and me, Deng Wei Wen. So first, our video will start with introduction, followed by cost analysis, and finally, the conclusion. Introduction. So a microchip, which is also known as integrated circuits, IS, refer to a combination of a flat piece of silicon and a set of electronic circuits. Transistor could also be found on the microchips, and it played an important role to switch the circuit on or off. So silicon was chosen as the material for microchips because it is a semiconductor. A semiconductor is a material in which its conductivity is higher than an insulator, but lower than a pure conductor. To change the conductivity of a semiconductor, a process named doping was introduced. When doping, impurities such as phosphorus and boron were added to the silicon so that it is possible to switch an electric circuit on and off. The other advantage of silicon is that they are made from sand, and sand is the second most common element on Earth. So, next. So the reason why we choose to sell microchips, to manufacture and sell microchips, is that microchips have become one of the most crucial electrical components, and it can be found in our daily life. For example, our smartphones, our car, and even our IC. So microchips, however, come with different performance and usage according to their build. Advances in chips have led to the creation of new products and the transformation of entire industry by offering higher performance, additional features, and reduced costs with each generation. To investigate the potential of microchips, research should be done certainly on the next sales of microchips. According to the data, the next sales of microchips technology has hit approximately 2.17 billion US dollar for year 2016. It then shows an increase from 2016 to 2019 with the net sales of 5.35 billion US dollar. For the following 2 years, the net sales remain similar. Nonetheless, the net sales unexpectedly broke $6 billion and achieved a total amount of $6.82 billion in the year 2022. Overall, the net sales of microchip technology is showing an increasing trend and should grow further as the demand increases. Next.
Okay, so now I will explain the cost analysis, and I will introduce the front part, and then I will pass to the Wenson to explain the break-even analysis. All right. So basically, our company is the factory manufacturer of microchips with semiconductors in Penang. You can see over there is Penang Bridge. All right. So the situation and information for us for this company is sunk cost, which including the construction and renovation fee, is approximately 341 million, and electricity is 550,000 per month ringgit Malaysia, and microchip manufacturing machines is 6,496 per unit. With 1,000 units, we need to sell and we need to produce. The manufacturing cost is 3.36 ringgit per chips, and each machine we have one operator to operate and produce 100 of microchips per hour. So salary of each operator is 20 ringgit per hour with 8 hours working day. All right. So the equation here is referred to table and graph for next slide. So this where we need the information that we gave we adopt from is from a website. So this website is which include the selling price of a microchip with respect to its demand from 2007 to 2015. So you can here is demand unit per year and selling price. Actually, it's in USD dollar, but we convert into ringgit Malaysia. So this is the graph from this table. Okay. So next for the company cost, this because cost we have the variable cost and the fixed cost. So the fixed cost is total annual salary with 1,000 operators and the annual maintenance cost. So approximately 50 million per year. And then the variable cost is the sum of the annual electric bill and manufacturing. So it will contribute to 845 million per year. So the total annual cost is the fixed cost plus variable cost is nearly 895 million per year. All right. So overview of the diagram for our project is we have into two scenario. This selling price per unit is considered as we need to find the minimum or maximum number of microchips needed to be sold. So and from that number we can find the minimum and maximum profit that we can earn. So for the case one, we had to consider the chips that we need to sell, how much per ringgit, so that we can earn the profit in the subsequent year. So we can find that 4 ringgit per 0.98 cent ringgit Malaysia per unit is the price that we need to sell so that our profit can be earned at the end of 2023. So for the case two, we did not consider any profit, any feasible for this project owner. So 3 ringgit and 60 cent per unit is the selling price per unit for we need to sell. So the fact from that we can find that factors that influence on profit is manufacturing cost, salaries of workers, selling price, and rate of production. But the management of the teams just because the management of teams just the operation when depends on what we do and the boss. So I think no need to include. So that will not influence on profit. So total revenue we to find is the profit. For condition one, selling price per unit is a function of demand. So you can find that by first derivative, we can find that this graph of total revenue against demand is like this, is a bad phase. So the second derivative is negative, shown the negative value. And for condition two, selling price per unit is independent of demand, is a linear graph, which total revenue is equals to 3.6D only, right? So next I will pass to Weng Son to explain the break-even analysis. Thank you.
So now I'm going to explain about the second part of the review, which is the break-even analysis. In general, break-even points is the point which separate the loss and profit. The points preceding the loss give us negative profits, and the points exceeding the break-even points earn us positive profit. Next. We consider the break-even analysis in two scenarios, in which in scenario one, the selling price P is completely dependent on the demand D. To find out the break-even points for this scenario, we first have to plot three graphs on the same graph. The three graphs is revenue, the total annual revenue, the total annual cost, as well as the fixed cost. And the intersection points between the line of total annual revenue, TR, as well as total annual cost, CT, give rise to a point, and that point is the intersection point, which means that is the break-even points for this scenario one. At this break-even points, we earn no profits at all at this point, and because we want to find the maximum profit for scenario one, we have to find the profit function, that is the subtraction between the total annual revenue as well as the cost. By taking the first derivative of the profit functions and set it equal 0, we found that the demand which is responsible for the maximum profit is about 4 billion units per year, and the total annual revenue due to the demand is approximately equals to 27 millions to 9 billion units per year, and within these profitable demands we can earn our profit with ease, and this range is basically analogical to the demands in between the break-even points as shown in the slide. Next. The second scenario is the case in which the selling price is completely independent on the demand. As you can see in the pictures, there is an intersection point between the total revenue functions as well as total cost, and the intersection point is also the break-even point, and the coordinates for it is about 237 millions and 856 millions. At this point, we earn no profit at all, and the point after the break-even point gives us a positive profit. And at the point of the profitable demands, that is at the break-even points, we found that the annual revenue is about the total revenue is equal to the total annual cost because of the demand, about 237 million units per year. Next, I'll pass to Nona-View to explain the remaining parts of the video.
So for conclusion, after going through all the cost analysis and break-even analysis, next slide. We can summarize that the selling price for microchip per unit in case 1 is 4 ringgit and 98 cents per chip, and the minimum selling price for microchip per unit and from the beginning of 2024 is 3 ringgit and 60 cents per chip, and the optimal value demand for maximum profit in scenario 1 is nearly 4 billion units per year, and the maximum profits for scenario 1 will be nearly also 4 billion ringgit per year, and the break-even point for scenario 2 will be nearly to 237 million units per year. Next slide. And here are the references that you can refer to. So this is the end from our group. Thank you for listening.